Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Izzatul Syahira binti Ahmad. We are from SR 11332. So today I'll be the first presenter. My group will present about response to exercise. Okay, so what is response to exercise? Response to exercise is body response to the intense demands placed on it by physical activity. It is changes that occur in the body as individuals regularly participate in exercise training. So these changes relates to improvement in the body's function, both of rest and during exercise. Okay, so what is acute response? So acute response is referred to immediate changes when performing a single bout of exercise. So how about chronic adaptation? It is referred to changes take place after certain length of time exposure to exercise. Okay, so let's proceed to the next slides. Systems that involve in response to exercise. Okay, the first one is metabolic response, second cardiovascular response, and the last one is respiratory response. So the next presenter is Muhammad Alif Haikal.
Okay, my name is Muhammad Alif Haikal bin Nazrin. I would like to continue Izzatul Syahira point. Okay, there are two types of exercise, which is aerobic and anaerobic. Okay, first we look at aerobic. Aerobic is exercise is more focused on cardiovascular training. It is a prolonged exercise but at the lowest intensity. It also requires slow twitch muscle fiber. Example of aerobic exercise is long distance running, swimming and also cycling. Okay, the second one is anaerobic. Anaerobic exercise is a high intensity explosive training. It's remain short duration training. It's also required fast twitch muscle fiber, and the example is anaerobic exercise is sprinting and also weightlifting. Okay, the second point is goals for aerobic and anaerobic exercise. First, let we go to aerobic exercise. Okay, which is aerobic exercise will enhance capacity blood, which is VO2 max, to deliver. The second one is enhance maximal oxidative capacity, which is QO2 muscles. The next one is anaerobic. Anaerobic enhance muscle lactate removal and lactate utilization, and the second one is enhance anaerobic capacity of muscle.
Hi, Assalamualaikum. My name is Ahmad Idam bin Ahmad Nizam. Today I want to present about metabolic responses. Okay, metabolic responses to exercise is indispensable for muscle contraction. Okay, so we go to prolonged exercise. Okay, number one is exercise longer than 10 minutes can achieve steady state then plateau. Okay, next we go to hot or humid environment to cannot achieve steady state. Okay, next we go to short term exercise. Number one is high intensity and short term exercise to 0 to 10 seconds to produce ATP through ATPPC system. Okay, so number two is intense exercise longer than 20 seconds to produce ATP via anaerobic glycolysis. And last one to short term exercise is high intensity longer than 16 seconds to produce ATP through oxidative system. Okay, so we go to incremental exercise. Okay, incremental exercise is oxygen consumption uptake. Okay, oxygen consumption uptake is to increase during exercise in proportion to intensity. Okay, next is maximal oxygen uptake to VO2 max to maximum amount of oxygen can deliver to muscle. Okay, next we go to cardiovascular responses. Okay, number one is heart rate. Okay, heart rate increase as intensity up to maximal heart rate. Okay, how to increase heart rate? Okay, due to sympathetic nervous system release adrenaline. Okay, Point number 2 is stroke volume. Okay, stroke volume is a amount of blood pump from the left ventricle is 1 beat. Okay, what cause stroke volume increase during exercise? Okay, increase ventricular contractility and decrease total peripheral resistance in blood vessel due to vasodilation. Okay, next point is cardiac output. Okay, amount of blood pump from the heart every minute. Okay, how to increase cardiac? Okay, as heart rate increase and stroke volume increase, cardiac increase during exercise to maximum. Okay, last but not least is blood pressure. Okay, blood pressure is systolic blood pressure to increase as intensity increase. Why? Okay, why? Because CNS, central nervous system, responds by vasoconstriction. Okay, that's all for me. Thank you. We pass to next presenter is Khairul Zaim Zafran.
So, hi and Assalamualaikum. My name is Khairul Zaim Zafran bin Karuzaki. I'm from SR113 3D2. So, I would like to continue our group presentation for blood flow. So, blood flow is acute changes during blood plasma. Exercise will cause an increase in total blood flow. So, sympathetic nervous system will initiate the blood to be redirected to active areas during exercise. There are two mechanisms which control the blood flow, which is vasomotor control. Vasomotor control are separated into two. The first one is vasodilation, which is dilation of arteries, and next is vasoconstriction, which is constriction of arterioles. So next, I'll move on to the AVO2 difference, which is arterial venous oxygen difference. This is the extent to which oxygen is extracted from the blood as it passes through the body. So in this case, it is calculated as the difference between oxygen content and also the right venous blood. So next, I will continue with plasma volume. Plasma volume is with the onset of exercise, there is an almost immediate increase in the loss of plasma volume, which is affected by, it will goes into the interstitial fluid space, increase the intensity and the environment, which is causing sweat. At 10 to 20% intensity of work or greater, it will reduce in plasma volume and can occur also in a prolonged work. So we'll move on to the blood pH. Blood pH will change significantly during exercise, becoming more acidic. Sometimes it will goes further down to 6.5 pH. So now we'll continue with the next slide. So next slide is what is respiratory responses. Respiratory responses is increase in ventilation due to mechanoreceptor in our muscles and joints. This condition happens during exercise. During recovery, ventilation decreases due to cessation of movement, and in prolonged exercise, it will lead to increase in carbon dioxide production and also hydrogen ions. Next is at low intensity, increases of tidal volume will occur. So next is factors that lead to increase in ventilation. So the factors are neural input from motor areas, body temperature, and also pH increases due to lactic acid. So we'll move on to breathing problems during exercise. First is dyspnea. Dyspnea is shortness of breath. It occurs because of inability to digest the PCO2 and also hydrogen. Next is hyperventilation, which is increase in ventilation that exceeds the metabolic need of oxygen. It will reduce by increasing pH. So next is Valsalva maneuver. Valsalva maneuver, which is breathing technique to trap and pressurize air inside the lungs. It is often used by athletes during heavy lift works. Next is voluntary hyperventilation. Ventilation is normally not a limiting factor. Respiratory muscles account for 10% of VO2. Respiratory muscles are very fatigued and resistant. It limits performance in highly training people. So I think that's all for our group presentation. I hope you guys can get benefits from it. That's all from us. Thank you.